So, today we're going to start work, because on Monday we managed to get sort of finish the pet version. I have no idea, Saucy. I don't know if Steve has seen the pet version. I have no idea. He didn't answer me on Discord, so I don't know. I have no idea. But I did have an email off FaiRLane, one of the patrons. Let me see if I can load it up. Right. And what he'd done, he's imagined how we could do a different ship, and this is it. This is what he'd done. So this is the ship, and then this is the shield that goes around it. Now it's really good. It's Minecraft is that still a game? I thought maybe it is the game. Mrs. OSK's playing Minecraft. Come on. So FaiRLane, one of the patrons, come up with this ship and shield combo for the pet. Yeah? But the problem is, if I put the grid on, right, the ship is 1, 2, 3, 4, 5, 6. What? 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4. And then if you have the shield on top of it, so you go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So we're going from a 4x2, right? So we're going from a 4x2 to a 4x6, and then for the shield in Myriad is a 4x4, and then going to a 6x8 would be too much of a code change just for the pet, I think, because it is rather massive. Because remember, this is the screen size, yeah. This is the screen size, so it does take a fair whack of the real estate. I know the ship is really nice. I do want to use it, but I just can't justify taking that amount of space on the screen for it. And also the fact that we'd have to rewrite the ship drawing part, yeah? It does look really good. It does look really good. Maybe once we've done the other things, we could come back and revisit it. But, you know, it means that we have to change an awful lot of the game mechanics for the dimensions and everything. So, yeah. So this is what he sent me, and I thought, oh, that's brilliant. But then I counted up the cells, and I thought, oh, it's big, it's big. But yeah, it's great. So we'll see. You never know. The Mega 65, if we have it in 80 column mode, we could have that. We could have that as a high res or Petsky mode, and have it like that. So I just wanted to show that off before we go any further. I've also, oh, that's a point. I've also, it can be included in the title screen. Ooh. Oh, now, hey, that's a good point, isn't it? We'd have to figure it out. Right. Also, Santa's come to me. Right. And I got one of these. Oh, I don't know if you can see that. Don't know if you can see that. Let me take it out. Right, that, you might be able to see it now. You plug that into your data set, and it's got a USB connection. So you can actually record directly off tapes, and So you can record the playback off a tape, and you can also play back on the computer, and you can record it on a tape. So I've bought this little gadget that will allow me, right? Because I've been wanting to do my bank account program that I used to use back in the there we go, it's better. Back in the 1990s. So look at that. Oh, you can't see that, can you? No. It's got my address from back of 1990, and it says financial package, because I want to show that the generous cable length. Yeah, it's a bit short. But there, yeah. But this, a Firebird case. It is a Commodore 64 128 Shahid Ahmed, whatever that is. So it could have been a Firebird case, but it's got two tapes in it, look. Right? I'll put my fingers over that. But it's got two tapes in it, yeah? So one, that's the program tape, and that's the data tape, yeah? And what I want to do is I want to capture the data on here and see if it'll run on an emulator, because I wrote two versions of the checkbook. It's a checkbook, finance package, budgeting package. Is he? Oh right. Well, I've got one of his cases, and so I wanted to move away. Squirrel. I wanted to move away from. You can see how rich I am. Yes. Well, if I do manage to digitize it, you'll be able to see how rich I was, and I wasn't very rich. But it's a budget. I wrote it myself to look after my finances, yeah. It ran on the 64. I first wrote it for the tape, because that's all I had, and then I converted it to the disk drive. And so I want to, as well, because I've been asked if I'm going to be doing any more application programming, yeah, and I said yes. You know, I was asked. It was said that I'm doing a lot of game programming and a lot of reverse engineering program. When's the next application coming out? And I thought, okay, fair point. So when we've finished Myriad, and if I can digitize this and show it off, I've got the D64 version, because I did a lot my disc digitizing a couple of years ago. AD type, and then we can start working on a finance program where we can use the 64 to run the house finances. Do the tapes still work? Yes, they do. They do, because I checked it on the real thing. It's one of the first things I checked. I've got a tape that works. So, data corrupted. Don't know. I've not checked that. I just checked that the program loaded. But I could do that. But I know the D60. I know the disc version of it. It works, because I have got it on a D64 anyway. But it's going to be another programming exercise where we are going to we're going to mix machine code and BASIC together. So we'll probably go back to CPS to do it, and write a household finance budgeting system that allows you to control all your finances, your checkbook, and all that. As just to show that the 64 could do more than just gaming, yeah. Because I've been wanting to do my word processor as well, and I've been wanting to do my databaser, But I thought doing the finance one. You'll learn about how to use databases on a 64. It'll be written in BASIC, and we'll mix machine code in there. Then I think what we could then try and do is see if we can write it all in machine code. To be honest, I'm just wondering whether we should write it machine code full stop. It will be interesting to see if we could do that. Controlling lights. What's that? What's that? The developer you are trying to view no longer exists in our database. Haha. Really? Was that the developer that's on the back of this? Oh, was that the developer on the back of this thing? Oh, I can't see it, can it? It's too bright. But it's spelt the same. Yeah, it is. It's spelt the same. Is that really the developer of whatever was in here originally? Wow. I'll have to find out what was in this originally. Anyway, so I just wanted to show that, and also to let you know what potentially the next software development could be. I want to write another application, and it was a toss-up between the bank account, as I called it, the bank account, and a word processor. So I thought it would be more interesting to do the bank account because there's databasing aspect in there, and it's all BASIC. It was all written in BASIC, so we could still do it in BASIC, and maybe convert it to machine code at a later date and stuff like that. But I do want to rewrite it. So yeah. Anyway, so that's what's been happening in the last couple of days. That I was asked if I was going to be doing any more apps, and I said yes. So I think we may do an application this time. C64 SQL database. Yes, it's not quite SQL, but it's all about databasing. So we could do all the different types of file handling and stuff like that in on the C64. All right, okay. I'll have a look at that later. CRUD. Yes, it's definitely CRUD. It's definitely CRUD. So we'll do that. Future. Yeah, I mean, my bank account program was sort of based on future finance on, but I couldn't afford it. I have Superbase 64 because I used that for all my. Do you know, in the 80s, and it was filer factors and all that, and I used Superbase 64 for all my contacts and stuff like that. But before that, I wrote my own database to do it. Anyway, so we did the pet version last week, and it came out, and it's come out pretty well. We've got sound. Let's load it up. Just to remind you all. So we'll load the workspace in and fire it up. Oh, I've got to wait for it to start up, Anna. Thank you. Oh, my sound's off. Did you hear that, by the way? Anyway, here we go. So as you can see, as you can see, we have got a pet version working of Myriad. God, die. Cool, that was close. Whoa! That was close. I can't get those diagonal ones. Oh, Iron Man mode. Nice. Come on, come on. See if I can get all the way to the next level. That cursor's come back. Look, the cursor's come back. I think we're affecting one of the 0 page locations, because that is definitely a cursor. There you go. So there's the pet version, yeah? So there's the pet version. So, what we got? You want to run your C64 spreadsheet now? Love. Oh, thank you, Tron. Love the explosions. Yes, it is pretty. It is pretty nippy on this pet, isn't it? I think it's. I think it's as fast as the C64. I think it is. Yeah. Anyway, so what we are going to do now is we're going to start the Commodore 16 version. Yeah. So we're going to miss the one. We're going to skip the 128. We'll come back to it. Yeah, because the 128 is just a slight deviation of the 64, and so we're going to do the Commodore 16 version. Could you also add a character ROM since it's software when you run on the emulator? Can you override the pet ROM? I suppose you can, can't you? I suppose you could. Just by redefining it. Yeah, to replace the pet character set. Yeah, I suppose that you could replace the ROM and define your own character set for the pet. That's something we can sort of do later on, because that would really need some thinking, wouldn't it? Anyway, so yeah, I had a Commodore 16. You're not going to believe this, but I bought a Commodore 16 thinking it was better than the 64, and then when I got it back and switched it on and realised there was only 12k in it, I gave it back and I demanded my money back. Oh. But I've got a Commodore 16. You've seen the box and it all works. It's got a bit of the keyboard's got a bit of a suntan, so it's going to need to be retro brighted, the keyboard. I've got a +4, working +4 with a working 1551 drive. Oh, by the way, did you see that 1551 drive on eBay go for like 450 quid? Wow. And I've got one of them. Anyway. Yeah, I heard that you can do it. I heard that you can boost the Commodore 16 to 64k. But it wasn't an option to buy back then, to boost it, from what I remember. I don't think you could buy a memory pack to expand it. Not that I know of. Anyway, so we're going to copy these two. Oh, will it let me copy these two? There we go. We'll paste it in there. We'll rename it C16. Rename this. Oh, it's the shop in Hungary. Yeah, memory was expensive back then. Yeah. Right, so let me just make sure that this... Right, we don't need that. We need to change that to C16. And, ooh, what is the run command? We're using 3.4. Where is it? Program files. X+4, that's it. memory's still expensive if you have an Apple badge on it. Yes, it is. Is Docster in? I ain't seen him speak, have you? Oh, there he is. There he is, the man himself. Hello, Docster. Right, so we should be able to load this, open up this workspace in C16 mode. There we go. There we go. There we go. Right, so we are defining C16. Took a while. Welcome. Oh, no, can you hear? Different colour frog. Can you hear it? She's found an orange frog. You can tell a new version of Minecraft came out, can't you? Right, so we've created the workspace. This is going to error straight away if I... Yeah, she's talking to one of her Canadian friends, I think. Or she's talking... Hang on, let me just have a look on Discord. Yeah, she's talking to one of her Canadian friends. Right, this will probably fail. Yeah, it will fail. Because there's going to be loads of things that we need to set up. Right, so. No, she's not streaming. She's in video chat with one of her friends. They're playing on... Mrs. OSK's got her own Minecraft server here. Behind me, a couple of rooms back, that she has her plays with her friends on there, and I've just updated it with the latest version of the software. So they're finding frogs and mangroves, and I'm waiting to see if the warden gets them. I'm waiting to see if they dare venture underground. See if the warden gets them. So, yeah. So, you'll be hearing lots of squeals and shrieks coming out of that room as she's finding all sorts of stuff. You what? Oh, I thought you found something. Right. So, we need a way of starting Myriad. First things first, we need a way of starting Myriad. Do we have a C16 start? Yes, we do. So we've already set up the C16 start point. So the C16 basic starts at 1000, And so we've got that started. Right, so we need to figure out where we're going to put the character set. Yeah? Oh dear. You'll be hearing a lot of this. There's 4 colours. Yeah, I think there's 4. I thought there was 4. Right, so we need to start out on the. I'm trying to find where I put it. Oh, I'm in the wrong place. GitHub, there we go. 64, Myriad. Right, Commodore 64. Right, let's grab the defined character set for the 64. Here we go. C64 frogs, 100 shades of brown. Yep. Right, so we're going to use, because the Commodore 16 uses the same character mapping as 64. Right, so here we go. So this is the information file that I've got on Myriad, yeah? So in multicolor mode, these bit profiles are linked to these. So we're looking at the C64 128 and the C16. And if you notice, they are identical. So we can use the Commodore 64 character set, yeah, for the C16. And that's what I've done. That's what I've brought it in there, yeah? So hopefully we'll be able to, you know, start figuring out what we need to do. So, right. So we need to initialize the game. Basically, we need to initialize the game for the C16. So now we put all the initialization code here. Maybe I should start splitting all this out. But we'll stick it in. So there's the C64. We'll copy that. We'll put it there and we'll say this is for the C16. So books, we need the books. Where's the books? So I've got 2 books. Right, I've got that one. And I have got this one. If it loads up. Is it going to load up? There we go. So we got these 2 books. And I have got these 2 books. I have legitimately got these 2 books, so if the keyboard warrior wants to have a go at me again, he can go and stick it where the sun don't shine. Right, so we need to, if my memory serves me correct, we made the game black on black, didn't we? So we need to find the addresses, and I think they were right at the back, weren't they? I think it was somewhere around here. Trying to remember where they were. D, that's where the RAM is. Processor interrupt. Oh, here we go. Here we go. I don't know if you guys can see that, so I'll make it bigger. It runs nice in warp mode. Oh, emulators are wonderful things. Right. So, we need to find what... the background and the foreground colours. Well, there's the voices. Here we go. Here we go. Here we go. Here we go. So 115 and 116. Right, 115 is the background. So that's the background. Ah, and there's the frame. That's the border. Right, so we can do that here. So black. Oh, right, we need to set up. So where's that? Machine constants. Let's set up some machine constants. Okay, Vic 16. Bookmark the page. Can you bookmark pages? How can you bookmark a page? Really? Ah, okay. We will add a bookmark. Right, I'll add a bookmark at the start, so which will be here. So Ted Chips. Let's add a bookmark there. Oh, well, I'm not paying for it, mate. I'll remember. What page is it? 180. I'm not paying something that I'll probably ever only use once. Right, so we need to add constant. So we need to find. So we've got the Vic there, got the pet there. Oh, you bookmarked all the pages. Oh, okay. Yeah, but it says it looks like you're going to have to pay for it, and I'm not paying for it. Right, here we go. So, we've got the C16 colours in there. That's good. That is definitely good. Right, now just need... Where's the Vic ones? Tell me where it is. Tell me where it... Why won't you tell me where it is? XO Duo, it's a free... Oh, it's free to bookmark stuff. Oh, right, okay. I'll have a look at that. Oh, I'm not sure it's in there. I think I've put it in a different place. Machine specific. Let's have a look if it's in there. No, it can't be in there. No, it's not in there. Constants. Right, screen and colour. Right, so we've already put... Ah, here we go. Here we go. It's in there. Right, let's put... Right, let's put another one in here. So, we're going to call this Ted, yeah? Do we have names for it? No, we don't. Okay, we'll call it background 0 then. Background 0 is FF15. So background 0. Right. Oh, might as well copy the rest of it. So we had 1, 2, 1, 2, 3, and another one. And then we had frame. Right then, so let's straighten them up. So 6, 7, 8, 9. Right, so they're the colours. Right, let's start this. So there's C16. Something to use my escape points on. Well, the gambling machine's on. You can gamble. Whoops. Oh, I've just lost a load of my credits. I'm not too sure how it works, Docster. Oh, Saucy's just won. Oh, and Docster's winning as well. Right, so we need to go Ted. We'll do there. Ted. And frame colours. So that's gonna set, so right. So now we need to set the character set. Oh, everybody's winning. That's it. You're winning all the points I've just given away. I've just lost another 10,000. I thought I might have got it back. Never mind. Oh, you're joking. You've just won it. Oh, dear. Right. So, high-res graphics. High-res graphics. Oh, here we go. Address of character set. Here we go. Okay, so. Right. So the character set's bit 2 to 7. Okay. Has this got anything about character sets? Have you got an index? Tell me you've got an index. You haven't got an index. Really? Okay. Character sets. 220. Page 220. Here we go. Characters. Locating a character in memory. The standard built-in uppercase and in lower cases are D1000. Blah blah blah. To tell the graphics chip to look at RAM, you must clear bit 2 of FF12. Bit 2. Right, so we need to clear that bit there. Okay, so this... Okay. This must be a control bit or something. Right, so we need to clear bit 2 of FF12. So 0, 1, 2. So FF12, what are we going to call that? Oh, we'll just call it character set address for a better one. I don't know. So I'll put that there. Oh, was it? Oh, it's not. It's not the character set, is it? Character set is 13. So, what do we call this then? Oh, bitmap address. That's what we'll call it. Bitmap address. I've already put passive cooling on mine, mate, and I did it for the +4. It's a bit of a squeeze for the +4. I had to take some of the fins off to get the case to close back up again. Right, so it's bitmap address. So let's change that to the bitmap address. So clear bit 2 to make it use RAM for char set. Yeah, I got those heat sinks that have got, it's like a fan. It's fan, so I literally just chopped, made it flat at the top. Still had the fins going out, but I just had to take, it was only about 2 or 3 mil off it, to make it so you could put the keyboard back on. Didn't take very long with a hacksaw. Right. So you must clear bit. Can you? By the way, can you read that? Let me do that. Right, here we go. So you must clear bit 2 of FF12. The character set is located by setting the high 6 bits of 13 to the high 6 bits of the character set location. Care should be taken to preserve the low 2 bits of FF13 because they are used for another purpose. Okay. Normally a character set consists of 128 byte patterns, 1K. Hence the character set location must be at a 1K boundary. Right. Any screen code generator. Oh, any screen code greater than 127 will produce a reverse screen image in high res mode. To expand the character set to 256, turn off the hardware reverse by setting bit 7. Oh, we're not going to be doing that. We're not even close to 128. Right. So we've got to set the address. So let me read that again. The character set is located by setting the high 6 bits of FF13 to the high 6 bits of the character set location. So where are we putting it? 2800. Yeah. It's amazing, isn't it? How little things. Right. Is that right? Okay. So we're using this. We're going to use this dress. Okay. So, so we're setting the address. So get rid of that. Come on. Character set address. Then we need to preserve what we've got. So we need to preserve 1, 2, 3, 4, 5, 6, 1, 1. And then OR it with and you reckon it's 001 01 000. So I presume that is to 2800, yeah? Okay. Right, okay. So I'll give you and Gary, because you guys worked it out. But I will take them away if it doesn't work. Right. So that's setting the character set. Right. Now this, what was that all about? Your precious points. Okay, so that Scroll X, I can't remember what Scroll X was. Cool, my memory's really bad. Let me just map in the 64. DO1 DO16. Wow, that was all that. 9, 8, 7, 6. Right, DO16. So, come on. So we're setting multicolour mode on. Right. Does we have a multicolour mode? Do we have a multicolour mode? Oh, let's go in the other book. High resolution graphics. Do we have multicolour? Extended colour. Multicolour. Here we go. You can shift the screen with the VIC-2. Yeah, that's the scroll offset, but it also had the multicolour flag in there. Right, multicolour characters. Choose multicolour mode by setting bit 4 of FF07. Right, FF07. Oh, there it is. Right, so, oh, this has got a scroller as well. This has got scrolling, hardware scrolling. Oh, right. Okay. Okay, so we'll call this scroll X as well. So ted.label scroll X. So we'll call it the same sort of thing. No, scroll X, which is $FF07. Yeah, but there's no names. There's no names on the locations, look. So I've just called it scroll X because that sort of maps it the same as the 64. Yeah, because it was called scroll X. But we're setting bit 3. We're setting bit 3. Oh no, we're not setting bit 4. Yeah, it's them. It's here, mate. I've already got it. Open, look. Scroll X. Scroll X, look. That's they called it the primary function of the register, even though it's got other things on there like the video chip reset and the multicolor enabler. But they called it scroll X. That's why I just called it scroll X. It's similar. Keeps us in the same thing. So bit 4 we need to set. Oh look, and 0, 1, 2, 3, 4, and it's the same bit as well. It's the same bit. Yeah, but there's 2 control registers. Like on the 64, you've got scroll X and then you've got scroll Y, which is I think further down. Wherever scroll Y is. Yeah. We'll keep it as it is. Right, so now we've set that. We can set the 2 colours now. So there's the colour, so we'll call C16 blue and C16 yellow. And they are going to go on TED 1 and TED 2. Ooh. Hang on. Go back to the book. Right, so... Okay, 15. What's 15? 15-0, isn't it? Yeah, 15-0. Right, that's right. 16 and 17. They're the 2 colours I want to set. 16 and 17. So 1 and 2. That's what I've done, I think. Yeah, 1 and 2. Right, set the volume. Okay, set the volume. I thought I saw that up here. Here we go, volume. there, FF11. So let's go in here. So we'll call this volume is 11 just to make sure, and it's the we have to switch volume. We'll call it that, voice control. So that's where the volume is. Right, so load 15. I think it was 15, wasn't it? Yeah, 15's loud. Load 15 into that. We're not banking anything out. So that should set up yes, the looks like the TED chip only has 2 voices from what voice 1 and voice 2, but voice 2 does have a noise, so we can use voice 2 for the explosion. We'll have to do a similar sort of thing like we did on the pet with the single voice and have a priority sort of thing. Right, so that set that up. So now there's going to be all sorts of other stuff. I think we need to just run it and see what falls out. So let's get storage on here, because that's going to fall out now. Storage. So we've got, so while we're here, twice what the pet had, so it should be amazing. Yeah. Right, let's see if there's any zero page stuff that we're going to fall over. There is one thing I want to see. Right, 0 page, where are you? Here we go. Right, so we're looking for things that possibly... How big is the assembled program of Myriad? I'll assemble it. I'll assemble it. I'll go into the 64 and I'll assemble it, and then we'll see how big it is. Right, so we're looking for bytes that potentially will cause us issues, yeah? So floating point doesn't matter because it's not running basic. Prompt, basic line, auxiliary pointers, not bothered. Product area for multiplication, we don't do any of that. Pointers for basic, no, we're alright. Y save, no, we're not going to be using any of that. Right, jump vectors for functions. I don't think, well, I think we'll be alright with that. Working area for sound. So I wonder if that's working area for the basic commands for sound. Run for graphic. Current graphics mode. Text. High res. Split high res. I think they're to do with basic. I think we're still basic. Kernel status. Yeah. The Jiffy clock is the first thing I'm looking for. That's what I'm really looking for, is a Jiffy clock. Default outputs, default inputs. No, that's fine. Here we go. Clock. This, so A3. So, okay. So we are going to... We'll do that. So A3 for that, for the C16 to A5. So that should be all right. So we'll go to, we'll kick it off at A6. We'll continue it on A6, which is here. So the problem is the kernel updates the Jiffy clock, so it messes around. If we stored anything there, it messed around with it. That's why we blank it off and bypass it. So anything else that we need to worry about? I like this R2D2 register. Is there anything else? Current voice, they're all kernels. Right, I think we're all right. Right. So, next thing is, where is the IRQ jump pointer? I wonder if it's in the customary Commodore place. Let's have a look. Yes, it is. Oh, and it even tells us where it goes. Nice. Right, so we'll grab that. That is in machine specific, I think. Or maybe not. Machine constants. I know it's around here somewhere. Or maybe not. Maybe it is in constants. Ah, it's here. Huh, staring right at it. Right, so the CVint is the CINV is the same place. So we just need, please be in this. Please. Here we go. IRQ return. There we go. Right. So equals that. Nice. Right, so let's just have a look. So we are, then we reset the high score. Oh, all the screen settings are going to have to be changed as well, aren't they? Oh, right. Let's go back to storage first. Let's just make sure we've got everything for everything. C was alright, wasn't it? The C boundary was okay. Yes. Ooh, C6 could be a problem. I don't think we go that far. C6 could be a problem. 1, 2, 3, 4. Oh, we bypass it anyway. We bypass it. Okay. C6. C6. This. That, I think that's 197 on the C64. But 198 on here. So we'll need to make a note of that. We are in constant, so he should be there. Right, so here we go. We need another one. Oh, that would be amazing if we could do that. But the problem is each of the programs have different start points. You know, they have different load points. That's one of the problems. Right. So, I'm just wondering. Right, 12K. 12K. How far is that? Is that 3,000? Right, so it's 3,000. Right, so we've got the character set at 2,800. And we need... Let's just put that over there. Oh, it doesn't tell me what the number is. Oh, that's really naughty. Right, so if the character set's at 2,800... Okay. That would take us to... That would take us to the end of RAM. Okay, so let's say... Let's say that we're going to start at 2,400. Number of bad guys. I need to find out where number of bad guys is. And I think that's not in there. I think this is in constants, isn't it? Number of bad guys. Oh, did I just say it? Oh, yeah, here we go. Number of bad guys, 32. 32 times... Right, so... 64... 64... Why don't the asteroids have a done? Have I... I'll look back to see what you're talking about there, mate. I'm just trying to work out. So, in the storage, we have 7. We have 7 elements. So 7 times 100 is 700. I think that should be enough. Because if we do 2,400 to 2,800, that's 1,024. So I think we've got enough space. I think we'll be all right. I think we'll be all right. So we can say that the C16 will work on this as well. Yeah. So we'll use the same settings as the others. Oh, we'll put the 128 in there as well. Right, so back to machine specific. No, back to where was I? Ah, here. So 2400 is where that memory's going to be. That should be okay. Right, let's start on these fellas now. So we still have the same dimensions for everything else. Right, the C16. Oh, we need to set color RAM. Where's color RAM set? Is that here? Oh no. Constants. Is that here? Here we go. Oh, color RAM set. Oh, have I? Oh, I've not spelt it right. Silly me. Silly me, not spelt it right. Right, so I assume that they're right. two grand for a version without speakers. Yeah. I'm sure that... I mean, they made such a big thing out of iMessenger that you could edit a message that you'd already sent for typos, when Discord have been doing it for donkey's years. Absolute. And they're making it, oh, look what we do. Right, okay, so color RAM. I'm trying to remember where color RAM was. Oh, oh look, color RAM's really early on. Oh no, D8, is that real? What's that? Oh, is this the hex value? What, the colour RAM? Oh, here we go. Yes, it is, isn't it? That's spooky. This... oh, this is the memory map for the C64. Good job. Good job. Have I been looking at the C64 all this time? No, please don't tell me I've been looking at the C64 all this time. Memory map. Right, we're on the right page now. Right, here we go. Oh yeah, colour RAM is at 800 and the screen is at C100. Yeah, so the colour RAM starts at 800, so that's what I've got, I think. Colour RAM starts at 800, the screen RAM starts at C100, which we need to remember. Right, so then all these... Why is that not liking that? Right, the raster. Ooh, that is gonna be fun. The raster. Now, I think I copied what we'd done for Petsky Matrix. I think. Let's have a look. Yes. So I just need to see. Right, so it's waiting for the raster. I'm in Petsky Matrix at the moment. Just trying to find what the raster is. But it looks like it's a macro, but I can't find the macro. This is Petsky Matrix, and I'm trying to find the raster macro. Can't find it. Huh. So have I got it in here? Utils. Yeah, I've got the same thing, haven't I? Oh, that's the Mega 65. What am I thinking? I'm looking in the wrong place. So I need to be looking for this. There we go. That's what I need to be looking for. And I've already got it in there, look. Vic Raster FF1D. Well, we'll keep it that because it keeps the code nice and neat. But let's just check. FF1D. Oh, I thought I had this written down. Oh, here you go. Oh, I've lost that page. Oh, there it is. No, I haven't. Here we go. Oh, I'm looking at this. We're looking at the wrong number. Right, 1D. Current raster. There we go. There we go. So the raster's the same, and we've got it defined, and we've got the number defined. Yeah, probably, mate. It probably can search. Right, let's F6 it. Right, key up. So this is now the keyboard. Right, okay. So we've got to sort out the keyboard. Oh. Right. So, let me load that keyboard routine that I'd done. See if we can work out the source code, git, stream, keyboard. There we go. This is the one. There we go. So we've got pet thing. So we've got different workspaces. So we'll grab that one and we'll paste it in there. We will rename it to C16. Drag it back to that. Right, so this is x plus 4. We don't need that. Oh, hang on. Oh, it's all changed, hasn't it? Right, we'll grab that instead. Plus 4. We don't need that. Right, so open workspace. Right, so we should be in Commodore 16 mode now. So what we need to do is we will grab that. We'll rename it and we'll make it Commodore 16. Right then, so our start position is going to be different, so we better make sure that that's right. So we'll just copy this. Right, okay, so we need to find Andy's mod here. Yes, I think so. Right, so we need to look at. We need to find where the CIA chip is. Okay. Let's see if we, right. That's the TED. Have we got? Where's the CIA chip? Okay, let's see if there's anything in here about CIA chips. Was it a CIA chip? I can't. I don't recall it being a CIA chip, but what would they be called? Just out of interest, what would have called it? Input-output chip? TED also handles the keyboard as well, does it? Okay, here we go. Right, let's see if the TED does the... Well, it definitely does the timers, which is a good sign. Keyboard matrix. Ooh. It's only an 8-bit number. Ugh. I hope you guys are looking for me as well. Well, there's the wiring diagram. This is just wiring up, isn't it? God dear, mate, how'd you find these things? So FD30 is the selector and FF08 is the answer. Right, okay. Let me just put that here. So it's saying that FF08, that's where the answer is, yeah? But to select it is FD30. But that's only the +4. Is this working on the C16 as well? Right, okay. Right, we'll work around this then. We will work around this. Okay, so we need to forget about these. So our set value is this one, FD30, and then we read back. Yeah, I'm just looking at the example at the bottom. Yeah, I'm just making sure. So FD30. Right. So we have our bit set, yeah. And then we rotate through it, and then we store it in the keyboard. Now, okay, so let's put the result. So the result for the C16 is at 8. Because the screen's at 0800, yeah? So we then should so we roll it and store it in. Right, that's wrong. Gotten the wrong way round. So we store it in FD30, we read FF08. Right. Okay, let's see if that'll run. Can't resolve start. What do you mean you can't resolve start? It's there. It is there. I wonder if it's moaning because I've got too many open. Hang on. Right. Wait for the thingy to fire up. Here we go. Why is it saying can't resolve start? It's there. Anybody got an answer to this? No, because we have to set it, yeah? For some reason it's saying it can't find start, but it's there. Why is it saying it can't find start? What? Right, so it's not that. Yeah, that should be the right address for the C16. Let me load PEX schematics up. Ooh, that's running a 64. Oh, that's because have I loaded? Oh, have I loaded the workspace in? Oh, it's not updated, is it? It's not updated. Hang on. Let's take that workspace here. Oh, emulator options. Ooh. And I've just closed that down, haven't I? Yeah. Hang on. That's what I'm after. Right, let's see if that will now fire up. Right, so that fires up. And that has got the basic, the basic upstart look. There. The only difference is it's got a small S for start. Maybe that's it. Oh, let's try it. Oh. Okay, why is this not starting up? I have no idea why that's not starting up. Can't resolve. Has it got to be in a block? I don't think so. I just don't understand why it's not finding that label. Everything else works. If I load the 64 one in, No, I'll load the Vic one in because that's using the same. That's using the same one. Right, there's the Vic. Oh, I've actually put. Right, okay. Maybe we have to do that. Maybe we have to do that. Well, that's a bit strange if you do. Right, let's work this out then. And we'll move that out the way and we'll put it down here somewhere. We'll put it there. Oh. Kick can be funny at times. Right, F6. Well, would you believe it? Right, that's not putting in the right place, is it? That's not storing in the right place. And it's not storing in the right place because the screen is at C, isn't it? Right. There we go. Right. 1. Okay, so we've got a problem. Right, let's go back to that article. Right, so each bit in the selector value represents a group of 8 keys. For example, bit 0 represents keys install, delete, return, pound. Right, yeah, we understand that. Bit 1, which is that one. Yeah, yeah. To read the group of keys, the corresponding bit must be 0. Yeah. The corresponding bit must be set to 0 in the selector value. The answer value is read from FF80, indicating which key has been pressed. If the key pressed corresponds to that. Right. For example, to detect space is there. Right. So 7F. Oh, hang on. Oh, hang on. F. These are... Oh, right. These are not the right... Oh, okay. Right, FE. That's bit... Right, FD. We know what FD is because that's the next one. Yeah. FB should be the next one. Yeah. It's an odd sequence. That's what's confused me. Right. F7 is that one. EF is that one. DF is that one. BF is that one, and 7F. Right, so we're doing the right thing. We're doing the right thing because we're rotating this way. We're going that way, right? So we're going across from this way, that way. Right, so let's just make sure we're doing this right. Space. So the selector value would be 7F. So that's what we've FD30. Right. Let's shut that down. Yeah, I'm just about to check if I've got a typo. Right. FD30. FF08. This is our value. We clear the carry. and then we go in. The first thing it does is roll left, right? So it's doing this. So we're starting at the opposite end, yeah? We store it into FD30, and then we read back out of FF08 and then store it in the keyboard matrix. So we're doing the right thing. The only thing that we're not doing is we're not actually setting whether it's, you know, so there's nothing in there about that. There's nothing in there about that. So he's putting set. I mean, I could hard code it. I could hard code it. I'm doing the same thing. Oh, hang on. Oh, hang on. They're storing in that one as well. Right, okay. Let's go back. Let's go back. So they're storing... Right, okay. So they're storing... They're storing it in there as well. And then reading it back. Right, let's try that. Here we go. Right, let's just make sure that we've got these things right. Right, so return. So return's going to be row 2. Or column 2 then. F1. F1. So I've got the displaying wrong. Hang on. Right, let's go back. So return is column 2. Yep. F1. There we go, that's F1. Was column, yeah. Okay, so so it's row. Alright, Gary, we'll see you later, yeah? Right, so we need to write these down. We need to write these down. Night, night, mate. So, we're W, right, W, A, S, D. We have the space. And we have return. So W is row 2. Well, row 1. 1 0 is the mask. A. Oh, is next door to it. Row 1. is that AS. Oh, still the same, row 1. But it's is that D? Right, that's row 2. That space. Ooh, that is 0, 1, 2, 3, 4, 5, 6, 7. So that's row 7. And return. Oh, he's up there. Row 1. Right. So we need to make sure. So I'll keep that there. Oh, row 0. Oh, so it is. Thank you. Right. Right, let's just see if, yeah, we can still multi-press. Cheers, mate. Spotting that. Right, so we now need to transfer this into hours. So I'm going to move that out the way, and I'm going to load it up. Myriad C16. And we now need to it's utils, isn't it? It's got to be in utils. Keyboard. Here we go. This is it. So the only difference that we've got here is we don't set this, which is what we've done. We don't set anything, and we're still doing the same shifting. So we need to go to scan keyboard. First of all, we need to put the thingies in, machine constants. I'm sure it's in here. Let's find CIA. Where is CIA? Oh, CIA. Let's do that. There we go. It's in constants. There we go. Right. So we've got to have a C16 somewhere. There it is. So label keyboard column equals $FF08. And we'll put another one here saying keyboard row equals FD30. Right, that will do. Back to here. Keyboard capture. Oh, it's not in there. It's in the macro, isn't it? here, scan keyboard, right. So we're still rolling, but we've got our own little thing going on here. So we store it in TED dot keyboard column. No, it's row, isn't it? Row. Store it in TED. Same thing, keyboard column anyway. And then we LDY TED dot keyboard column. And then we store it. So that should do the scanning of the keyboard. Now we just got to set the masks, haven't we? Here we go. So this is the Commodore VIC. There's the PET 16. Right, okay, let's see. Can I borrow? Well, we'll just borrow the whole thing. So we write to port A, which is FD30, and read FF08. Right, let's just do this quickly. So the first row that's that way around, isn't it? Just try and get them in there. Return. That's that one. Shift E S Z for A W 3. I will do the rest off camera. Right, so we're talking, right, key up, which is W, which is matrix +1, and the mask is the same. Right. W A is left, which is +1, and the mask is the same as well. S is down, that's 1. Would you believe it, the mask is the same. D is right, is row 2. And the mask is not the same. So that's down. And then we've got shield, which is space, that's row 7. And the mask is that. Oh no, it's not. Oh, it's the same. And then return is row 0. So fire is row 0 with the mask not there, but there. Right. We're getting there. What have we missed now? Oh, it's the back colours. It's the colours. Right, so the colours were in constants, I think. Here we go, colours. So, I wonder if the colours are the same. I wonder if the multicolours are the same. That you have to add 8 to the colour to make it multicolour mode. Oh, let's go to the go back. Multicolour mode. Characters there. 204. Right, okay. Right, so each byte in the character determines the 8-pixel touch. Yeah, we know about that. As you can see, the first 3-bit patterns use the global color source. This means that the 3 okay. Using the bits sometimes restrictive. Right, when the +4 is in multicolor mode, the color, not luminance, chosen for a given character cell determines whether the character occupying it is high resolution or multicolor. If the color associated with a given cell is greater than 8, then the cell is multicolor. So it's the same as the 64. Right. So, let's grab this. So, C16 is what we need to do. Right. What do you mean you can't find C16 black? I thought we had a whole rack of colours dedicated. There, C16. Machine constants. C16 underscore black. C16 underscore black. Oh, hang on. Ah. I wonder if we need to do that. Nope. Oh, have I cocked up here? No? That's Elfis. The reference to yet undefined symbol. Why is this erroring down here? Oh, okay. Why is this not liking it? We're if C16 and we've defined C16. Oh, it's a constant. Oh, I've made them constants. Okay. Machine constant. Machine constants is after. So that's why it would be complaining. But when it's done that way around, it should be okay. Oh, hang on. It's here. This is complaining about core constants, isn't it? Right, change. We're going to change it. Find in selection. There we go. Dot const. Change it to dot label. Right. C16 light red. So have we got a C16 light red? No, but we have a C16 pink, so we'll go with that. Right, now we're talking the screen positions. So, Start screen. Start screen. That's got to be in this. Maybe not. God, then it must be in this then. Start screen. Oh, no it ain't. Oh, I should have organised this better. It's not in there. Here we go. Here we go. It's here. Right. So our start screen is C. Oh, that is going to cause a bit of a problem, isn't it? The colour delta. Oh, no. Oh, dear. Right, so the colour delta is going to be 04. But instead of plus, it's going to be minus. FC00 and hope it doesn't carry. I don't think it's going to work like that, mate, because this is the assembler working it out. So it's going to be a minus. So start screen is there. End screen is that. Blah, blah, blah. So colour is going to be minus. Minus the delta. So let's get all the colours sorted first. Right, I think that's all the colour deltas done. So, I wonder if this is it, because it's the same dimensions as the C64 and the PET. Let's see. Does it load now? Oh, ooh! Now, why is that? We are almost there. Why is that? That's got to be something to do with... It's got to be the utils. It's got to be utils. Print title screen. Here we go. Oh, we wrote this thing. We wrote a macro to do all this, didn't we? Do I do the same thing again? Yeah, it's got the same. It's the. Oh, go away! This this extension. This extension's having serious problems. It does not like big projects. Right, I think we need to do that. And I think we need to do that. That should reset it, yeah? Then it displays the screen. Let's try that. Let's see if that puts the screen on. No, it's still in high res mode. Let's fire it up manually. Right, so we're looking at 65298. So 11000100. Maybe we should just do that. Store 96 in it. See what happens. Nope, it still don't like it. So let's look at that then. 65299. $208.
John, pay attention to chat.
Right, okay. I will look at that, mate. I will look at that. I'll look at that off stream and see if I can I'll reorganize it. Right. So the problem is it's not putting it back into normal mode for the screen, right? Oh, we're so close. We're so close. Well, we're back. We're back in normal mode, that's for sure. But we are missing. What are we missing? It's not moving on, is it? Decode the screen. Oh, it's missing the spaces. Oh, just remembered. It's missing the spaces. We haven't coded for the spaces. No, yeah. We've got no Commodore 16 spaces. Right, so the Commodore, yeah, we'll just put it on here. I think that's it. Right, okay, let's do that. Let's see if we get a screen. Oh! The F1 is not reversed either. I think it's the reversed characters. I think it's the reversed characters. Because look, F1's not reversed. But I thought they had reversed characters. Yeah, they should be. No, I haven't set the red background. Let me set the red background. Yeah, I hadn't set the red background yet. Right, let's try that. Whoa. Yeah, it's very dark. But still, the reverse characters are missing. Yeah, let's fix the F1 first. Find out why that's... You've been sneaking on my streams. It's supposed to say Myriad, but it seems to be not displaying all the characters properly. That's why we're tackling the F1 first, because that's the one we can find quickly. Right, it's down here somewhere. Right. So this right, so this has got to be it, hasn't it? Really? So this is the multicolour. This is the last line. So 20 something 1 space 2 something 1. That's got to be it. B1. B1 is B1. What's B1? B1 is reverse 1, so it is reversed. That's reversed 1. And that's reverse F there. So why is the reverse not coming up? The standard built-in uppercase graphics set are located at D0. The upper-lower sets are located in D4. To tell the graphics chip to look at RAM, you must set clear bit 2, which we haven't. We've set it to the normal. I wonder if we can do reverse here. One 007. No. You mean this one here? No, we haven't. Maybe, okay, let's do that. Well, in fact, what's 1007? 65287. 8. Right. Oh, there we go. Oh, look, the C16's highlighted. It's very dark. Oh, no. Yeah, it's fixed. The Myriad sign, but it's very dark. It is very dark. Maybe use orange instead of red. I wonder if it's the luminance. What's all the luminance about? Is that the luminance? Let's try it on the background, yeah? Constants. That's where the colours were, wasn't it? No, it's machine specific. Luminance. No, it's not in there. Machine constants. Got to be in here then. Here we go. Right, orange. I mean, there is an orange, but I think let's stick a luminance on it. So let's stick luminance 2 on it. Yeah? I'm just wondering if that makes it brighter. Oh. Made it a bit more wishy-washy, didn't it? So made it a bit wishy-washy. So luminance 0 is normal. So 1. Let's try 1. See what that does. It's very dark. We'll have to try the orange. I mean, that's... I think part of the problem is the text is so dark. Right, that's 6. I think, yeah, that's 6. I think we can go one higher than that. Yes, can go 7. That's almost white. Right, so what I'm thinking, right, this is what I'm thinking, is the decode. The decode, ooh, that's going to be good. Even that's going to be troublesome, isn't it? How about the same colour as the standard basic colour? Well, that's what it's set to. Whatever. I mean, I don't know what the standard basic colours here. I mean, these look pretty light. Let's find out what the border is. Border, frame colour. Here we go, frame colour. 65305. 65305. What have I just done there? What did I hit to do that? 238. So that's, oh, that is, Shift Commodore. What's the Commodore key? Yeah. Oh, that's thrown a fit now. I was trying to think how we could make the. I was trying to think if we have the background dark, we could have all the characters light. But it's yeah. But we're using the same decode routine for both the screen and colour RAM, so how are we going to differentiate between the two? That's a really good point. Um. How are we going to do this? Right, we need to put the. We'll come back to that in a minute. But after we've set it, we need to put it all back. We need to put the writing back. So. That goes back to that, and then we need to copy all this lot, don't we? Right. F1. Well, that sort of worked. That sort of worked. It put the character set back. I think it did. That's what we're doing up here. And then it should return and start the game. Should return back to here. I wonder if the IRQ is not being set. Maybe that is something we need to look at. No, that's right. We need to do the alternator. That's something that we've got to do. I wonder if we have to acknowledge that the IRQ's fired. So let's just do this. Let's make sure that we've got it going. So let's grab that. Yeah, probably. I think that's left over. I think that's left over when we took out the kernel. Right, that should do that. Right. We'll see if it's doing the kernel, doing it now, because the multicolour should blow. I don't think we're pointing the character set to the right place. I don't think we're pointing the character set to the right place. We're not overwriting anything, are we? Ooh, this is interesting. We're encroaching. Oh, we're encroaching. The character set's at to 800, isn't it? Yeah, it's gone into the bad guy table, hasn't it? But we've got the character set at 2800. But I don't think we're pointing at the character set. Are we officially running out of space? Definitely running into the bad guy array. And you guys said that this was the address. It was set to. It was set to. Hang on, let me find out. Let me find out. I can't remember myself. Let me just load up the workspace for it. Myriad. Vic. Well, we'd put the 8K on it. Let's just go into it. Is it there? Is it there? Is it gone off now? Oh, it's gone off. It's gone away. Oh, more. There we go. That's not the Vic one. Is that the Vic one? No, that's the original. That's the Vic one. Wait for the extension. So the 8K expansion. I mean, we can just reset this, can't we? Reset, soft reset. Yeah. So yeah. If if we can fit it in that. But does that give the indication it's gone over? That's gone over, hasn't it? You can certainly find out. There's a small gap there. Only a small one though. Game code start. Yeah. But the 8K would be, if it's an 8K model. Oh, come on, John, you get your brain working. So it would yeah, it was gone over the memory, because the 8K Vic would be up to 3,000, and we've gone way past 3,000. So it no longer fits in 8K. It's strange how Vice allows it to work though. Yeah, so it's strange how Vice has allowed it to work. But oh, hang on, but hang on, the Vic's different, isn't it? The Vic's memory map's different. The memory map's different because the 8K, right? The 8K is bolted onto it, isn't it? So this is the normal RAM that we normally get, yeah? And then you bolt 8K onto it, so it's actually going. So that's the 8K. So it is fitting. It is fitting in, because we get what we get. On a standard Vic, you get 4K, yeah, and it goes up to 2,000. It goes up to 2,000 because the screen is at 1E something, yeah. So when you put 8K onto it, you bolt it onto it, so you end up with 8K Yeah, in standard configuration, it's 5K. You got 3.5K of usable space, which is this here, this red section, because half a K is taken up by the screen RAM. Yeah, and you've got the red section in 0 page up to 0400, I think it is. So it turns out to be 5K in total. So you got 4K there plus 1K here. Yeah. So that's 5K plus 8. But the 8 is bolted on after this. So it's 13 in total. And that's why, because it would be, if we'd gone past 3 FFF, we would have been in trouble. So that's why it's fitted into the 8K, because the 8K VIT is because the 8K is bolted on. It's not continuous memory, because this memory doesn't exist when you put an 8K RAM stick in. Yeah, it doesn't exist. Right, so that's okay. We now figured out why it works in a VIC. But there is still a big gap there, so we could do something about that big gap. Right, let's go back to the C16 and see if we've got an equivalent gap. Can we move the colour map though? Oh, does it remember? Oh, it's remembered for the previous one. Right, F6. We'll let it run through. That's strange how the character set's not appearing on here. That is strange. Oh. I don't need to define high res. I don't know why it's got if high res. It's always going to be high res. That's why we're probably not seeing the character set. Let's try that. There we go. We're overlapping the character set. Let's move this to D 8, 9, A, B, C, D, E, F. Yeah. Let's move it to that. Let's check that. 2C 1 2 3 is 001 011 001 001 011 001 011. Right, let's see if we... Right, the character set's out the way. Oh, the character set's there. We have no bad guys because we've overrun it. So, let's see. Where could we put the bad guys? Oh, Saucy says 2900. Right, let's try. Where's the bad guys? Oh, I'm in the wrong place. It's storage, isn't it? 29. Okay. Let's do that. Okay. F1. Now, we don't have any sound, because we haven't done it. But look, we have a working game. We haven't got... We don't seem to be having any flashing going on. Have I got the IRQ wrong? Let's try border 1. Oh, no. Wrong one. Let's try that. No. Oh, yeah, 1. Let's try 1. See if we get the flashing going on. Nope. Try frame. But this we're changing this character here. That's the one. Oh, see if it flashes the frame. Okay, I see what you mean. See what you mean. It's not, is it? Yeah, it's doing something. I think that's where the IRQ's been is firing. Where we're doing the raster. I think, but it's not doing anything else. I mean, some of these characters are not multicolour. That's another thing that we need to sort out. They all should be multicolour. So we're gonna need to look at why these colours are not colours. Oh, see you, Phase. Night. Well, what I'll do is let's put this back how it was. Colour 2. I think, look, I mean, we got some weird colours coming out of here. So there's going to be some changes. Maybe the colour generator. We need to look at the colour generator because clearly, the multicolour generator doesn't seem to be working because that's pink. Maybe it's doing a luminance value, and that's why it's come out like. Because it did say that if you set the luminance, then it doesn't go into multicolour mode, does it? I think that's what it said. Right. The bits of the colour below, but the foreground determines the lower bit, the high bit is whether the character is interpreted. Right, there we go. For the foreground colour is determined by the lower 3 bits of the low nibble. The high bit from the low nibble determines whether the character is interpreted as high resolution or multicolour. Thus, high resolution characters and multicolour characters may be mixed, but only the first 8 colours are available for both types. There is no hardware reverse. So, is that saying that the high order bit on the lower nibble determines whether it's multicolour or not? And I think that's what the problem is. I think that that's coming up as, I bet the multicolour generator is generating a number that doesn't have the high order bit set. So what we need to do is make sure it is set no matter what for the C16. So let's just quickly go into there and have a look. So it's definitely in utils, so let's look in utils. Find multi. Ah, here we go. So we haven't got a way of turning it on, which needs to be this here. Yeah, so we need to do this. That. Right, let's have a quick nose and see if we've got some proper characters now. Oh, it's not doing it. Maybe we need to do it. It's the same sort of thing as that. Maybe it needs to do that. There we go. There we go. Nailed it. Nailed it. Right. So, we have got a working C16. So it needs luminous. So in the next stream, we're going to try and figure out how we can take the colours that we've already got, yeah, and illuminate them for just the C16 version, yeah? Because I don't want to have to go through all the colours to set them. What I'd rather do is go, right, we need to, for the C16, we need to do this for all the colours. We need to give him a luminous factor of 2 or a luminous factor of 4 and have that done on all the colour settings, yeah? So we can either do it at the point we set the colour or at the point we determine the colour. I think it'd probably be better at the point we set the colour, that when we display it on the screen, go, oh, is this a C16? Are we in C16 mode? If we are, add this luminance value to it. And that's what I think about that's what I'm thinking about the decode screen. So on the next stream, we're going to first fix the colours, get the luminance value set right, because what I want to do is have the black background but everything's standing out. So we're going to have to give it a luminance value of maybe 3 or 4, something like that, just to make them stand out. And then we will check that all the keyboards are working, and then figure out the sound bit of it and do the sound with the 2 voices. Yeah. So it's been interesting because we're having to learn a new hardware. Yeah. We have about 80 more bytes of code before we hit it. Oh yeah. Well, I don't think we'll. If we do at point of storing in the color RAM, where we test whether it's a C16 and do the luminance value there, I think we'll get away. I think we'll get away with it. Yeah. But yeah. Right. So it's been a bit of a learning curve. Luckily, we've got these books. That are. And I like this Scott one. It's going to be tight. Yes, it is. But it comes really close to C64. Was easier than the PET, I think. Yeah. The sound, hopefully, won't take that much space up. Hopefully. But it's going to be close. It's going to be close to the point that we may have to sacrifice something. Yeah, we may have to sacrifice, or we have to do a major optimization run and start optimizing and get some memory back. All right, guys. Well, it's close to midnight for me, so I thought the TED was only 2 voices. 2 voices. I thought it was just 2 voices. Voice 1 and voice 2. Yeah, it's only 2 voices. The TED's only got 2 voices, but it does have a noise channel, but it's on voice 2. But it's, at least we've got, yeah, voice 2 can be noise, that's all. But at least it's one more voice than we had with the PET, and we did pretty well on the PET, so it's just a case of working out which sound effect goes on which voice, that's all, I think. Alright, so, well, thank you very much for joining me. We're doing alright. And I like going back to these systems that I'm not familiar with, because it's like rediscovery, isn't it? It's like rediscovery. And I hope you're enjoying this as well. So, yeah, hopefully we should finish the C16 one on Monday. Hopefully. And then we might swing back to the 128, and then we'll take it from there. Alright then, guys. Well, thank you very much for joining me, and I will see you on Monday. Take care. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.